We're almost there, you guys. Okay, so suppose I know the derivative of a function g. I know the derivative is the square root of x. And I also know some point about g. Suppose I know that g of 4 is 2. Hey, notice the square root of 4 is 2. That's not why g of 4 is 2. Actually, let me change the problem because I don't want that to be confusing. Suppose I know g of 4 is 9. The square root of 4 is 9, but g is not the square root of 4. That's the derivative of g. And also the square root of 4 is 2, not 9. So like this is talking about one function, this is talking about a different function. They are related, one is the derivative of the other. But yeah, how would I know g of 5? So I want to know, I can know anything I want about g. In this example, I want to know these 6 unknown things about g. How would I find g of 5? The thing I know is that g of 5 minus g of 4, why 4? Because 4 is the point I know, is the integral from 4 to 5 of the derivative. Integrating the derivative from 4 to 5 gives you what's the difference in the values, 4 and 5. This is the rate of change. Integrating it gives us the total change. How much do you grow by? How much is g going to change by between 4 and 5 is the integral from 4 to 5 of the derivative of g. What is that? That's a thing my calculator can tell me. I want to integrate the square root. Ooh, that's a gross function. Let's start clearing this out. I'm done with these problems, I hope. Let's integrate the square root function. Or I start by graphing it. I need to go out to 7. This graph goes out to 7, so this is fine. So I calculate the integral from 4 to 5. It's 2.12022. Let's call that 2.12. Let's keep 2 digits for this problem. How many digits do you need to keep? I don't know. I don't usually care. Don't stress too much over the digits. Keep a bunch. So we just found that, I forgot the number, 2.12. G of 5 I don't know. G of 4 I do know. So G of 5 minus 9 is 2.12. So G of 5 is 9 plus 2.12. The 2.12 is saying how much do we need to increase by. 9 plus 212 is 1112. How do I get from here to 6? I want to add on what's the integral from 5 to 6. Or I can add on what's the integral from 4 to 6. I guess 9's an easier number to add in my head. Let's do that one. Let's calculate the integral from 4 to 6. What do I get? I get 4.46. If I add 9 to that, 9 plus 4 is 13, I'll get 13.46. If I integrate from 4 to 7, lower limit of 4, upper limit of 7, I get 7.01 plus 9 will make this value 16.01. What about if I go to the left? Being able to write this equation out is helpful for going the opposite direction. G of 4 minus G of 3 is going to be the integral from 3 to 4. Let's solve for the thing I want. I want what's g of 3, so I'll add the g of 3 to both sides. And I'll subtract the integral from both sides, and I get that g of 3 is g of 4 minus the integral from 3 to 4 of the square root x dx. So like, the integral tells me how much do I need to add to go to the right. It tells me how much do I need to subtract to go to the left. Let's do the integral and then subtract that number from 9. Let's calculate the integral from 3 to 4. It does an annoying thing where the part that it shaded last time, it never unshades that. So it's going to show me too much shading, but it did the right thing, assuming I typed in the right thing. Is 1.86, that rounds to 1.87. I want to ask what's 9 minus 1.87, and it's 7.13. I want to ask for the integral from 2 to 4. Calculate the integral from 2 to 4. And it's 3.44. I want what 9 minus 3.44. It is 5.56. Maybe I did the rounding wrong. I don't care about that right now. Let's calculate the integral from 1 to 4. I think this one's going to be a whole number, almost a whole number. 4 2/3. What's 9 minus 4 2/3? It's 4 1/3. So this one will be 4.33. So yeah, the integral tells you how much do you need to add. So you add that on to go to the right, and so you subtract it off to go to the left. There's a few versions of this homework in the problem where, so there's versions where it's like this. I give you the derivative and say, now fill in a chart of values. You need a starting value for everything else to be in reference to. There's one version in the homework where I give you a graph, and so you're calculating the integral not with a calculator but by hand. When you're working on this, if you're searching YouTube for stuff about integration, it should give you a heads up that on exam 3, we're going to be integrating functions by hand without a calculator. Right now, you don't know how to do that. The YouTube videos you search for help with these problems might not know we haven't covered that. If you get to a YouTube that ever talks about an integral that doesn't have the little numbers here, or does it by hand, you can ignore that part. For now, every integral we do will be a definite integral, meaning it has the little numbers, and it'll be a thing we just ask our calculator to compute for us. We'll later be doing the more complicated thing of doing these things by hand. But yeah, this is the end of the topics on exam 2B. Exam 2B is going to be this Friday, April 10th, unless I hear complaints that that's too soon. I don't know if that's too soon. Feels like the right length of time. I don't know. Hey, you know how I haven't cared about homework deadlines all year? I still don't care. If you need more time, let me know what's going on. Cool, that's it. Oh, I forgot to post the notes for the last thing. I'm gonna post those. I guess you already saw them there if you saw this. I'll stop talking now. Where's my stop talking button? Damn it.